Modeling class, week 6. Today, there's one final thing that I didn't get to cover when we were talking about characters, and that's just adding an armature so that you can put it in different poses. So we'll go over that quickly, and then we'll be done with character creation stuff for a little bit. The next topic is advanced lighting and materials. So we'll talk a little bit today about just kind of generally like some things that I like to do with lighting. And then we'll talk about materials and using the like shading workspace and using nodes and things like that. And just like talking about nodes really in general. So real quickly, I just want to wrap up characters. So you may remember this guy that I made a few weeks ago. And I just want to put a quick armature on him so that you can just see how to adjust your character and put him into different poses. Because remember, part of your assignment 1 is to have your character in 2 different poses, have 2 different renders. The first thing I guess I'll show you how to just make a basic, like a super duper basic armature. And then I'll show you just like a little bit more advanced thing if you want to do that. So the basic way to make an armature is to add a bone. So in our scene here, I'm doing an orthographic view because this also makes an impact on it. But you can Shift A, add down in here armature single bone. So you notice that I have these other things, human and animal and basic. These are part of the built-in Rigify add-on. So if you go to your preferences and go to your add-ons and search Rigify, R-I-G. It's a built-in thing. So you probably should enable this, and I'll talk about using it in a second, but first I'm just going to add a single bone. So Shift A, I'm adding an armature, I'm going to add a single bone. And before we do anything, so you can see it puts it at your origin point here. I want to go to my object data properties. I can never remember which one this is. Yep, so it's in object data properties here, so the green little person, and I'm going to turn on int front so I can see it in front. I feel like sometimes when I do these, I like take in a deep breath and I'm like holding my breath and I have a real long sentence and then I run out of breath. Anyway, so I'm going to treat this as like my spine. So I'm going to go GZ. And so in case you've forgotten everything about bones in armatures, bones have 2 kind of pivot points or joints and then like a direction. So like this bone is kind of moving up. So, and I'll talk about that in a second. So I'm just going to do a couple up the spine, and then I'll do a couple out the arm, and then a couple down this way. So to build off of this one bone, so I'm just going to kind of scale it down. And again, this kind of depends on how you want your character to be able to move. Obviously, it's very important for animating, but if you're just kind of going to be messing around a little bit, it's not you don't have to. It's not critical to get this exactly right. So I'm going to hit tab for edit mode. I'm going to select this top one, and I can hit E to extrude and then Z to line it up with the Z. So I'm just going to do 3 EZ kind of up to here. And if you're just kind of doing this without using an add-on, it's good to label these. So like select here in your scene collection and just be like, this is spine 1 and this is spine 2, just so that like you can kind of keep track. Spine 3. And then over here, I'm going to E-extrude like this. And I'm just going to do one side, and I'll show you that there's a quick way to kind of just duplicate it across the other side. So this will be like shoulder here, maybe. And then I'm going to E-extrude to like elbow, and then E-extrude here like this. So like this one will be, again, so, and you'll have to kind of twirl these open to kind of see them cascade. So that's this spine 3. This would be, and here the labeling is important. So this is going to be shoulder dot, and I guess it depends on your perspective. It's shoulder dot L because it's his left, I'm going to say. And this is going to be bicep or upper arm dot L, and this is going to be forearm dot L. So the dot L, it all signals that you have to have a dot L at the end to signal that like this is the left side of it. And then I'm gonna do the same thing down here. E extrude here. I'm gonna E extrude. I'm just gonna have one. He's not gonna have bendy knees. So this one I'm gonna name hip dot L, and this one I'm gonna name. I gotta open this one up. This is gonna be leg dot L. And then I should also just like have one or two for the head. So easy extrude here. This one could be neck, and then easy to the top of his head. So this one is going to be, I gotta twirl this one open. This is going to be neck, and this one's going to be head. Great. Okay. Now I believe it's as easy as selecting all of these. And if I go armature, let's see, there's a symmetrize button. So it says, enforce symmetry, make copies of the selection or use existing plus X to minus X. So here, if I just hit that, you can see that it generated these bones on the other side. So easy. And then what you can do to kind of refine the armature a little bit is you can turn on this apply changes to matching bone and opposite. So, and actually looking at this, if we open these up, so now we have a shoulder R, upper arm R, forearm R. So they have the correct labeling. So like here's hip R, leg R, the correct labeling for each side. And so then when you turn on this button here, apply changes to matching bone on the opposite side of axis, it'll know how to do that. So like if you move this one, you can see it moves it on the corresponding side. So I think the last step here is just to like get the side positioning of this right. So let's see, this one is gotta be here. I just want to grab the end here and move that forward. Get the head right, and really like it. This, you can spend more time doing this definitely, but this I'm just kind of, this is a silly little dude. Maybe I should move his shoulder like down here. Okay, so let's call this good. So next step is to parent these together. So to actually allow this armature to move the dude. And maybe you want more bones. Maybe you want something for the nose, so you can animate or move the position of the nose, or maybe you've got hair or things like that. So you can have more detail. Okay, and I always get the ordering of this wrong. So I believe it's select your mesh first, hold down the shift key, and then select the shift click on the armature. Control P brings up your parenting menu. Whoops, Control P. And we want armature to form with automatic weights. Dunk. And now you can see that Bruce is parented to armature here. And if I'm go select my armature, and we can now go into pose mode up here. If I move one of these things, that's going to kind of move his whole deal. So obviously it's not, I haven't done this perfectly because I probably wouldn't want his side fat to move with it. So what you could do is you could undo this a couple times and just change the positioning of the bones, or you could go back to your object mode, click on the mesh, and adjust some of these vertex groups with a weight paint. So like the area of influence here is shown by the color. So like this right now, I've got right leg selected here, and you can see all of the area that moves when I move the right leg bone. So what you might want to do is paint a weight of 0 all the way around here and say like, yeah, don't move any of this when I move that bone. F to make your selection bigger. I gotta turn on key and stroke so that you can see my key and strokes. Let's go. So yeah, you can adjust this if you want, or just leave it as is. The other thing that can be useful if you've got longer limbs is to add a bone constraint called inverse kinematics, and this one can actually be really helpful. So like rather than, if I select the armature and go back into pose mode, rather than like moving this bone, and then moving this bone, and then moving this bone if I want the hand to wave. Undo, 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 undo. You can add a bone constraint to the end here. So if I select this last bone, the forearm, and go down to this bone constraint properties tab here, this blue one, you can add a bone constraint that's called inverse kinematics. And if you do this, it'll move the bones further down the chain according to how this moves. So like right now, if I do this, it's going to like wiggle his whole body. That's because our chain length is set to 0, so it's going to go all the way back to the beginning of the chain. 0 means just like do the whole chain. But we could set this to 3. So we say only move 3 bones. So you can see that this orange dotted line now points back to here. And so by moving this one, it's going to wiggle these things around it. But obviously keep them connected. I can't stretch it any further than the bones would actually move, you know? So that's one thing you can do. Now also notice that when this was 0, like the eyes and the face weren't are still there, or the eyes and the teeth. So one thing you can do, actually I don't know why, where are those in my object here? But anyway, you can select these, shift click, and then also shift click on the armature and just run your parenting again, armature deform with automatic weights. And so now, if you select this, go back to pose mode. Now they are parented. So you can do that armature deform to as many different objects as you want. So like if you have like a different object that's like a hat or something, you can also parent the hat to the armature and move stuff around. Okay, so let me see if I can undo all the way back to when I did this. I can't. Okay. So what I'll have to do is just, if I go back to object mode, I'm going to remove the parent. So if I select the armature, I can go Alt P, clear parent, like this. Did that do it? Actually, I think I have to go like that. I have to select the mesh and do Alt P, clear parent. There we go. Okay. So the armature is separate from Bruce. Okay. So I'm just going to delete that armature. I've already spent more time on this than I wanted to. So Rigify, the add-on I talked about at the beginning. So we can, if you go Shift A and go to armature, you can add a basic human as well. And, you know, again, display in front here would be helpful. And you can go into edit mode and, you know, make this how you want to. GZ. Adjust these things. So it basically already has, and make sure that you turn on the symmetrize, or not symmetrize, but apply changes to opposite axis here, and you can move all these bones around and do whatever you want. So that's another quick way to do a rig. But I think if you have a simple character, it's probably just as easy to make your own quick armature. And then same thing applies. So if you go select your mesh, then shift click on the armature, Control P, armature deform with automatic weights. And we've got this meta rig. And then because we use the Rigify, one of the Rigify add-ons, Rigify armatures, you can also do this generate rig thing here. If you click that button, it creates some controls for you. And then you're able to reparent it to this rig. So you can hit the mesh, and then shift click on the rig, Control P, armature deform with automatic weights. And obviously I didn't actually set this up very nicely, but then you've got these things that can control the hands, things that can control the head, etc. Things that control the feet. So I went through that super duper fast. But that's just those are kind of easy ways to. That's how you can reposition your armature or your character using an armature. Okay, and I guess the one other thing I'll say, if your character has a lot of detail, so let me undo this a few times. Delete all these. Okay. if your character has lots of details and you want to be able to like change the face and the fingers and things like that, there is a more advanced human meta rig like this. And if I hide Bruce, you can see all the detail that this has. So this has like individual eye control, face control. It's got, 10 fingers, and well, it doesn't have toes, but like, you understand hopefully how to add bones for parts that you want to move. If you have questions about this, email me because I'm going over this pretty quickly. Okay, so just to add a quick armature to your character and do like a couple of different poses as part of your assignment 1. All right, so let's talk about lighting for just a few moments, and this is definitely like changing, or like we're on to the next topic for the semester, and lighting is important, and I think for a lot of people that are starting off in 3D in Blender, it's sort of like a last minute consideration that you'll spend a lot of time modeling something, and then it's like, okay, I'm just gonna throw up 2 point lights, or maybe 1 point light, or a sunlight, and call it good. But I think good lighting can go a long way. So I just want to explore the different types of lighting you can use, and what makes it look good. So to start, I just want to talk about Cycles, the Cycles engine, actually. So right now I'm in Eevee. So again, if you are in your render properties here, it's the back of the DSLR camera. I think in the modeling class, let's try to use Cycles. And don't forget that if you have like a GPU in your computer, which many of you likely do, you can change your render device from CPU to GPU. And this will likely be a little bit faster because this is what GPUs do. A GPU is a graphical processing unit. And, they're used, I think people use them a lot for playing computer games, video games, but those games render things in 3D. So Blender renders things in 3D. So if you don't have this GPU compute option when you select Cycles, don't forget that you can go into your edit menu and go to preferences and system on the left here. And you can choose here under Cycles render devices, you've got options for what hardware it's using to render. So if you have NVIDIA graphics card, it'll be under CUDA or optics. If you have a AMD graphics card like myself, it'll be under HIP, HIP. And you can select it, and then you should have this option for GPU compute. Okay, Cycles. Why is lighting better in Cycles? Well, because it is ray traced, meaning, let me actually just go to render preview here. So Shift A. I want to add a plane as well. So a ray traced render means that your GPU is calculating the rays of light. It's tracing the rays of light as they flow out of your light, where they're hitting and then where they're bouncing next. And this is done through sampling. So here in the very top thing in your render settings is sampling. And this, so what is in my viewport here, it is rendering, or it is sampling 1024 times. And how it kind of works in Blender is it slowly does it. So like when I move my camera, you can see it's kind of fuzzy, and then it kind of quickly gets a little bit nicer and a little bit nicer and a little bit nicer. The other thing that's happening is you're seeing noise. So even though it's like taking a little bit longer and slowing down, you can still see that it's kind of fuzzy right here, and that's because denoise is turned off. It's just another thing that can happen when a computer generates 3D. So you can turn on denoising here in your viewport, but I think it'll slow it down, and most people understand that there will be noise in the viewport, but you can remove the noise in your render. Okay, so cycles is tracing the rays of light. Eevee, it kind of fakes it a little bit, and I'm not exactly sure how it works, but my understanding is that like what Eevee and other kind of and I'll use the word lesser. What Eevee and other lesser renderers will do is it won't trace the light. It won't trace the like bouncing of light around. It'll say like, okay, if a light is here and an object is here, this is where the shadow will be. So it sort of like does math to just project where a shadow for a thing will be. So just looking at the difference here, so like, look at this corner right here. So, my box is intersecting with this plane, and it's sort of like, I don't know what to do with this shadow. And also like this edge is a little funky. It might get a little bit nicer if I were to actually render this out. But that's just sort of an example. If I switch over to cycles here, you can see that's like, yes, I'm really working hard to determine where the shadows are. And this is another thing too. So like you can see that right where the thing making the shadow is casting it, the edge of the shadow is really sharp. But as the shadow gets further away from the object, you can see it's kind of a fuzzier edge here. And that's because our light has like a size. And so the angles that the light are hitting this top corner are varied. So there's like more light being blocked here and less light being blocked here on this side of the shadow. So that's just something to be aware of. The other thing to notice here in this particular view is a phenomenon known as ambient occlusion. So even though, there's just one light in this scene, and actually, what I should do is I should turn my world color to black, so you can see it even better. So there's only one light in this universe here, and it's on the other side of the cube. Yet, I can still see that this side exists. It's not just like infinitely black. And that's because like the light kind of bounces around. So like, the light is hitting back here and there's a little bit of reflection happening here. That has something to do with your materials, which we'll talk about today as well. But what I want you to see is like right along the edge here, like right along, like it's darkest right here. And the phenomenon known as ambient occlusion is that like when things are closer together, there's just less light reflecting around them. So it's a more realistic look. Anyway, I kind of nerd out about lighting a little bit. All right, so I'm going to remove my cube and I'm going to do something just like a little bit more interesting, and I'm going to add a Suzanne into the scene here. And so like immediately you can see that like just lighting is a little bit more, looks a lot nicer with cycles than otherwise. Just because like you're getting like a little bit of, light reflecting off one side and the other. I'm gonna just kind of make this a little nicer. So what Shade Smooth does, by the way, just to have another boring context, is it kind of, so actually let's look at the difference with if Shade Flat. So like here with Shade Flat on, you can see that there's like little squares. And what Shade Smooth will do is it will just kind of look at the squares around it and try to kind of change the shading from just like 100% flat to give it a little bit of gradient, so it hides the edges here. So it's just doing a little bit of extra math to make it appear smooth by just kind of evening out the colors and the shading of each of these squares. So shade smooth is your friend here. All right. Now, point lights are fine. You are definitely allowed to use point lights. But I actually really like to use area lights. My dad was a photographer, and he always had these big soft boxes when he would do photography. And it just gives things like a nice even light without harsh shadows. So if I go to light here, I'm going to add area light. Geezy, I'm going to move it up like this. And let's see, where's my light properties? Power, turn up the wattage and turn up the size. So you can, so here's kind of a little experiment. So I have a very small light here right now. This area light is small, and just like take a look at the shadows. So you can see that like the shadow is pretty well defined. You can see the ears, and there's like the eyebrows sticking out. As I make the size of my light bigger, you can see the shadow gets smaller and softer. And like the lighting on the top is more even. So this is just, just understanding the differences in lighting. And so maybe I'll take this and I'll just kind of, I'll move them over here, and I'll, point it. I'll make it a little bigger, and I'll try to point it at there. I'm honestly like sometimes a little sloppy with positioning my lights, just because I kind of want to do it fast and get the gist of it. The other thing to be aware of is fall off, and I think it's called the inverse square rule of lighting, that like if you double the distance a light is from the object it's lighting, if it's 1 meter away and you go from 1 meter to 2 meter, you're doubling the distance. You're cutting the amount of light by 3/4. So you're left, like, if you move it, if it's at 100% brightness at 1 meter, it's at 25% brightness at 2 meters. So that is a rule for real life lighting, and because we're trying to do realistic lighting here in Blender, it also applies. And Cycles is doing realistic lighting. So you may need to, if you move your lights further away, you may need to up your power of the light. And also just like take note of the effect that it has on the shadow of your object. So like here, if I move this light closer, obviously it's brighter, but the shadow is kind of extended out a little bit further. But if I move my light further away, my shadow gets smaller. But also because the target of the light is smaller in comparison, it also is a little bit darker back here. So just like so many fun dynamic things that are happening with lighting. And and maybe this is just my style, but I like interesting and dramatic lighting, and I feel like that's most often achieved in like a dark setting. And that's just maybe the aesthetic I like. So Shift D, I'm going to duplicate this light and point this here. So looking at Suzanne here, it's kind of interesting. It's sort of unique. But I think you should attempt to have 3 lights in your scene, and to serve different purposes. Like, if you just have 3 lights all in the same, like just pointing at the front of it, you might as well just have one big light. That's not a big deal. But if you took any videography classes at Hemp and Tech, or at whichever school you're at, you maybe looked at 3-point lighting. So you've got a key light, which is sort of your main light. A backlight, which is often behind your subject, that kind of creates sort of like, or like a rim light, they'll call it, that separates your subject from the background. And then a fill light, same side as your key light, but opposite side. So it just kind of eliminates shadows and things like that. And you're welcome to experiment with that too. So again, point lights are fine. I feel like previously I've given point lights a hard time, but they're just fine. And also play with like the colors of light too. Like sometimes a backlight is a great excuse to use something like a little bit more exciting. Like maybe make it just like give it a little like green tint or something like that, just to kind of add a little personality. So I can see that like looking from this angle, I'm getting some green on the back, but I kind of want it on the hitting the top. So I might GZ move this up a little bit, and then G kind of move it a little closer. Let's get my camera in a little better spot too. Yeah, just like a little hint of green. This also might be a better occasion to use a spotlight too, if you want to like really have directional light, but originating from one spot. The other thing too, so point lights, even a point light has a radius too. It's not truly a point, so you can make it larger or smaller, and change the bounces. And so a larger or smaller point light will also affect the shadows. So imagine like having a singular point is going to create pretty harsh shadows, but if you make it, the size of a light bulb, the larger your light bulb is, the softer your shadows are going to be, because it's going to be like emanating from more angles. Okay, so now this is a good stopping point for lighting, and because I want to talk about materials. All right, so the ultimate pairing is good lighting and good materials. So, let me preface this by saying you are allowed to use materials that you find online, for sure, 100%. Because it's like, the analogy I use is, it's like taking a math test, or like the ACT or SAT or something, and like using a calculator. Like calculators exist. We don't have to pretend like calculators aren't a thing. You don't have to like do the math by hand. So just like there's a lot of people that have made really great free materials online, and you are 100% able to use them. It is also my responsibility to teach you how this actually works, because inevitably there will be a time where you can't find the perfect material. And you should be able to either find a way to create your own, or find a way to alter an existing material to get exactly what you want. So, and actually, why don't I even just pull up a couple right now? Oh, actually, I forgot to share this. I saw this on Reddit the other day. Why isn't this working? Here we go. I haven't seen this movie, but the movie Nope, by Jordan Peele. He did Get Out, but anyway, I saw this picture of them lighting this movie set, and they had this giant softbox on a crane and another one on another crane here, and I just thought it looked cool, because I just love these big soft lights. I thought it was pretty special. Anyway, okay, where to find good materials? Here's one. Polyhaven. I actually go here to find HDRIs, which we'll talk about in the semester. But they also have some cool textures and some cool models, and many of it is free, obviously. So you can find some cool stuff here. The other one is Polygon Runway. Polygon Runway. And they actually have an ad. No, is this it? No, it's not Polygon. What is it? Hold on. Oh, all their names are so similar. That's why I'm mixing that up. It's Polygon. Poliigon. This is if you follow Blender Guru on YouTube, this is his stuff. So they've got some great textures here. If you go to textures, and you can sort by free. F for free. And there's like a bunch of just really cool free textures that you can just throw on there. They have a plugin that you'll need to install, and you can follow the instructions on their website. So if you go to Polygon and scroll down, I think, yeah, here. Fast importing with Polygon plugins, and there's a Blender one right there. They got a video showing you how to do it. But a lot of times you are going to want to find a texture that you want or create your own. And the first example I'll show you here is hardwood floor. So I'm going to use my search machine to do hardwood floor texture. And let's go to images here. And when you're searching for images, you want to have a large image, for lack of a better term. Usually at least 1,000 by 1,000 pixels. And obviously bigger is better. So if you're, I'm using DuckDuckGo here. And actually, I haven't really, let's do sizes. If we do large, can I even, I think you can just sort it by large. But I'm just going to kind of scroll through here to find one that's like sort of, looks sort of nice. And also, it's really helpful to have something that's square too. Just as a general rule, that a square texture will tile a lot nicer. But anyway, so here, let's look at this one. This one is 1024 by 1024. That's fine. Let's view this file. Seems fine enough. So I'm gonna right click and save this image as, and I'm gonna call this wood texture. And I'm gonna save it in my fall 2022. This is the modeling class. Save. Okay. So now on my plane here, it's a square, and I also download a square. Let's add this texture. So I'm gonna go to my material tab. I'm gonna add a new one here, and rather than base color here, I'm gonna check hit this little yellow. Oh, and my face is in the way. There we go. So I'm in the materials tab, material properties. I added a new material to this. And base color, I'm going to change from just a regular color to an image texture. And then I can hit open, this open button, and go to my fall 2022, go to the modeling class, and open up the wood texture. Done. Okay, so by default, and actually, you know what, maybe I should just make this a little smaller, because I can see from this distance that it looks a little pixely. So, you know, maybe you can find a little better, bigger one. But anyway, so when you just bring in an image texture like this, it's going to make it the same sort of like flat texture shininess as everything else. So like looking here, if I bring up this angle right here, you can see that right here, one of my big area lights is reflecting on this, and it's like reflecting too perfectly. That if you had a hardwood floor, you'd expect to see like some bumps and some cracks and things like that. Now there are a lot of cool and tricky ways to do that without actually like modeling the bumps and the cracks, and that can be done through nodes, using nodes. And what do I mean by that? So let's actually go over to our shading workspace up here. So if you just have like the default layout of Blender going on, you should have the shading workspace up here. And so if you don't see it, you can hit the plus add a workspace here, and it should be in general, and shading is down there. Okay, so many things, our workspace has changed quite dramatically here. So what are we seeing? First, this is your like node workspace down here, and you can actually see that there's a few nodes already connected. We'll talk about that in a second. Excuse me. I'm drinking a LaCroix and it gives me hiccups. Uh, the other thing here, our viewport has this HDRI. So if you don't actually, I need to move my camera again. I'll be over here, actually up here, because we won't use that. So I'll make myself bigger. Okay. So here, in our viewport, we are seeing, this is material preview, actually what it's brought us to, and it's got an HDRI, so we can kind of see how the light is reflecting around on our subject. You can also change this to just render preview. That might actually be more helpful. Down here, this would be a UV editor. I actually don't know when we're going to be talking about UVs, but we will at some point in the semester. So this is kind of our node workspace here, and then we've got regular stuff going on over here. Your scene collection and all of your tabs for things. Okay, so let's talk about what's happening here. So we've got 3 nodes here in our node view here, and they're attached with these little noodles. And you may recognize this green one here. It says principal BSDF. So this is our material. And so so I've got my plane selected, and I go down to my material properties here, like this, all of these things are exactly reflected here. So we've got, it says principal BSDF, you've got subsurface, color, metallic, specular, all of these values are also here. So, and you can see that if I change the metallic here, it changes it over there. To the right, we have material output. So this is kind of the ending of everything. So we kind of work left to right. So we're generating this principled BSDF and outputting it to our material output on the surface of it. So like there's also volume and displacement. So like, and I think we'll cover these later as well, but like volume is sort of like the inside of a thing. So like if you had something that was transparent or like had smoke or something inside of it, that would be the volume, and displacement is also just sort of like how much it's affecting the position of things. Okay, so we're moving left to right. So we also have over here on the left our wood texture.png. Now a node has sockets on the left and on the right. The things on the left side of the socket are inputs, and the things on the right are outputs. So these, think back to like your high school algebra or whatever. These are like function machines. These are things that like do math and calculations. You put things into it, it does math, calculates, and then spits stuff out. And the final spit out is here, our material output. So actually, I believe you can see that if I disconnect this here, it goes black because it's not going out to our material. So to connect, and so these are called sockets. I may have already said that, but to reconnect, you can just click from one and drag it into another one. So the general idea is you're connecting colors. So like you connect a green with a green, you connect a yellow with a yellow, and you gray to grays, and there's purples and stuff too. But basically, the important thing to understand about these different colors now is that a gray is a value. And it's a value from 0 to 1, or it's like a decimal. If the value is 0, it's 0%. If it's 1, it's 100%. So you can see for the most part. So you can see like specular here goes from like 0 to 1. Same with roughness, goes from 0 to 1. So actually you can see if I turn my roughness down to 0, we can see our lights being reflected in here, and Suzanne being reflected in there. Kind of cool. So you can also have nodes output to multiple things. So like I could take the color from our wood texture and also try plugging it into one of these other things. Like why don't I plug it into roughness? So you can see that like, we lose the ability to adjust the roughness, but it's like, it's taking, it's looking at the color and like changing that into just like values between 0 and 1, because this is a gray socket, and attempting to kind of adjust the roughness of this based on like the color of it. So it's not working perfectly, but you can see that like in spots where it's dark, it's much shinier, or the roughness is low, and places where it's lighter, it's not as rough. So you can see like right here, we're seeing a really good reflection of the monkey, but like here we're not, because like this is a darker part of it. So you know, you probably wouldn't actually do this, but then you can also add things in between. So like well, no, I'm not going to cover that next. So just as an example, I'm going to disconnect that. I want to show you a node that you can plug in that's usually kind of fun to use, but it's called bump. And so to add a node, you can add nodes in here, and also just so you know like how to navigate this. So it works just like your regular viewport. So you can middle mouse wheel in and out to make this bigger or smaller. If you click and hold middle mouse wheel, you can like move around and shuffle around like this. And Shift A is also the same way to add a new node. So if we do Shift A, and you can just click search, and you can just start typing. So the one I want you to search for is bump, B-U-M-P. And so it's going to drop a new node in here, and you can just put it anywhere to make sure that's not intersecting one of your lines, because if you drop it on top of a line, it's going to attempt to you know, make connections here, but we actually don't want that. So we just want this to go right into here like that. So bump. And what a bump is going to do is it's going to adjust the normal of your material by making it appear like it's kind of moving up and down. So what you can do is you can connect the normal from bump into the normal of your principled BSDF. Nothing's happened yet, but what we can also do is take the color and connect it to the normal here. And actually, no, well, why don't we connect to the height? That'll probably make more sense. Okay. So you can see what it's done is it's actually like it's created little like shadows, and it's made it look bumpy. And so you can invert this too, I guess, to like make it flow the other way. It doesn't make that much of a difference, but then you can like turn down the strength a little bit, so it's you're seeing a little bit more of the reflection. Turn down the strength. Maybe change the distance so the bumps don't appear to be as high. But this is like kind of a cool thing you can do to like add like texture to a material without actually adding like geometry. So it's kind of like doing math to make it look a little fancier. Yeah, well, you can play with these a little bit. What else can I show you here? All right, and let's pause really briefly, and I just want to show you. We're talking about actually what a BSDF is. BSDF. Let's see what the search machine has to say about it. Okay. BSDF stands for bidirectional scattering distribution function. But it's basically a series of math that is done to determine how light bounces off a surface. Bidirectional scattering distribution function. So like this image right above my head kind of summarizes it, that like how, like, depending on a surface, how light bounces off of it and how light is transmitted through it. So in Blender, a principled BSDF, let me switch this again, is sort of like, it contains everything that a material can do in Blender. It's so like it's the default because it has all of these different parameters inside of it. So like roughness, sheen, charcoal, or not charcoal, clear coat. I can read. All of these things are, this is everything. So real quick, I'm gonna just add a new material here. So I've got the plane selected. I'm gonna do a plus. Oops, I already did a plus. I'm gonna select this one here, hit new, And I'm going to change this from a principled to the one of these other ones. And these are sort of like templates for other things. So something that you might look at is glass. And actually, instead of putting it on here, why don't I put it on? Let me remove that from the floor. Let's actually put the glass on Suzanne. So with the Suzanne selection, I'm going to do a new one, and I'm going to change the surface from a principled BSDF to glass. Okay, and so you can see that now we have a lot of things missing. Well, not missing, but there's a lot less control over this. So like, you can change the roughness of this, but we can kind of see through it a little bit. We can see the wood texture coming through. There's a couple different these things, Sharp and Beckman. These are different like calculation methods. So you really don't know what it'll do until you click it and play with it. Change the roughness of it. If its roughness is 0, it's like super smooth. You can see right through it. But if you turn up the roughness a little bit, IOR, I forget what this actually stands for, but this also kind of has to do with like the transmission of the light through it. But anyway, so a glass BSDF, and you can technically achieve this look with a principled BSDF. You just change some of these things. So like transmission goes like up to 1 like this, and then it's glass. But so these kind of presets or templates kind of help you get there along the way. So like velvet has a particular look. You can change the sigma value of velvet, whatever. Tune is maybe one that you play with and can have fun with. You can give it like that Borderlands look. Or that, whatever. Glossy. Anyway, the other thing I'll show you is emission. An emission is like another way to have lights, or to create lights. So an emission surface will glow basically, and it will just cast light onto your scene as well. So this is a cool way to have like a neon sign. So like if I want to add text in here, I'm going to call this like neon. Did I do this in last semester? Maybe I did. And then we can oops, I'm getting emails. And then we can go into the geometry here and just extrude it like this. And actually, let's change Suzanne. Oops, I'm still in edit mode or object mode. Let's change Suzanne's material away from emission and just make it regular like this. And let's take our neon, G, move it over here, R, rotate it like that. And let's add an emission material on here. Emission, make it really bright. Change it to like a pink color like this. And it's a pink neon. Turn down my extrude a little bit so we can see it a little better. There we go. And it's a pink neon light, but also is like something in your scene. So that's a cool thing you could do. Okay. Whoops. So that's the different types of materials. Just kind of a preview. I want Suzanne to be like really metallic. So let's up the metallic like this. And turn down the roughness so it's sort of like chromed out. Cool. Okay. Let's play with our floor material a little bit. So we've got this wood texture on here. Let me just delete that. So I'm going to delete my wood texture here, delete my bump. The other thing you can do is you can generate materials. And so there's a few that you can play with built in here. So if we're in our node workspace here, we can do Shift A and head down to texture. And these are a few different kind of generative textures you can use. So image texture is obviously one where you can select an image, but like Voronoi is kind of a cool thing. So if we put, you can just click to add your Voronoi texture in here and just attach color to base color here. And let's just see what it looks like. So it kind of makes this cool color pattern. And you can change the randomness of it a little bit. And you can change the scale of it. Euclidean. And you can kind of change the shape of it as well. Manhattan. I think these are the names of mathematicians, like Chebyshev and Minkowski. Euclid. Euclid. I've heard of Euclid, I think. The other thing, 3D and 2D. So this is like if you're putting this, whoops, not 1D. If you're putting this kind of a Voronoi texture on something that is three-dimensional, you'll obviously want to do it 3D because, like on Suzanne, it wouldn't be it would look funny because it kind of projects it flat. So you'd have to just change this to 3D. I don't know what F1, F2 really does. What if I hover? What does this say? Computes the distance to the second closest point as well as its position and color. Scale. And like some of these things you just experiment with. So like what happens if I plug the position into the normal like this? What does that do? Oh, I don't even know. Didn't really do anything. Clear coat normal. What happens if I take the distance and turn it into, make it metallic or something like that? Oh. So the distance from like the center, oh, what if I put it on the roughness? Let's see what happens here. Let it render a little bit. Yeah, so it kind of seems like it's the distance from the edge maybe is what that distance value is. Specular. Yeah. So some of these things you just experiment with. The other thing too, okay, so that's Voronoi. Let me delete that. Let's go Shift A. I want to add like a brick. This one's pretty easy. And let's put the color into base color like this. Brick texture, great. So here we have the mortar. You can set the mortar color, also the mortar size if you want. Oh, whoops. I made this some chunk in my system here. Motor size, there we go. 0.1 please, I think. Oops, 0.01. There we go. That's a normal mortar size. So, okay, so this brick texture here, this is a great example actually. Factor. So the factor is it's generating a value between 0 and 1 based on the color of this, based on the grayscale. And I should say the lightness of it. So this is going to create a map that says, okay, where it's black, the value is 0. Where it's gray, the value is like 0.5 or 50%, and where it's white, the value is 1 or 100%. So if I take the factor here and I plug this into roughness, let's say. So we can see that, like look here where Suzanne is reflecting. Where the tiles, or like where we have the black mortar, the value is 0. Or it's inputting a value of 0 in these areas. So the roughness of it is, well, and now I think I'm maybe getting this backwards in my head, but like there, it's and actually now I think it is flipped. It's not reflecting at all where it's black here like this. Where the colors are lighter, that's where it's getting the reflection. So you kind of have to get creative, and you kind of have to like understand how your math works a little bit. But let's say I wanted to flip this. That I said like, oh, I actually want the mortar to be reflective, and I want the bricks to not be reflective. What we can do is you can actually just add like simple math right here in between. So Shift A, and you can search for math. And you can just, if you hover right over one of these little noodles, you can see that this green one lights up. And what I have done is you can just put two values together and have a function to do the math. So like right now, it's doing add. what I want to do is multiply. And so it's right now it's multiplying this value by 0.5. And we can even just say multiply it by -1. And oops, oh no. Actually, so this actually isn't the one you want to use in math. There is a simpler one that's called invert. So if I go Shift A and I search for whoops, not that one. Shift A, search invert, INVERT. You can drop this right on here. You can see that it flipped it. So now the black areas are the shiny part, and the brick areas are the flat part. Okay, and you can change the amount here. So like if the factor here is 0.5, it's going to kind of flip them each halfways. If it's the factor is 0, it's not going to invert it at all. If the factor is 1, it's going to invert it 100%. So like these are like very, very basic uses of nodes, and we will explore we'll do some more exploring of how to get this to create things that you want further on down the line. But for now, you don't have an assignment to work on this week other than finishing up your character. But I encourage you to just kind of experiment with some of these. Put a texture on here. Put a magic texture. See what a magic texture looks like. It's magic. What if we set the factor to the roughness here like this? So you can see that where there's more happening, it's shinier. The roughness is low. Where there's this other thing between the thing, the roughness is different. Anyway. Okay. It's been 1 hour and 1 minute. Thanks for watching this week. Don't forget, so you don't have a weekly, you don't have anything else. I just want you to finish your character. And don't forget that you need to render in 2 different poses. So when you submit your assignment 1 for grading, please do 2 different poses, 2 rendered images of 2 different poses, and submit your Blender file as well. Thanks. Have a great week. Goodbye.